They said it couldn't be done. Too many launches, too much refueling, too complicated to ever work. SpaceX's moon plan, they said, was simply too much. This week, NASA gave us the number. At least 15 Starship launches to reach the moon once. It should have proven the skeptics right. Instead, the math tells a very different story. And at Starbase, a mysterious new part just appeared on a Starship nose cone. I think it's the first hardware for the one capability that makes the whole moon mission possible. Oh, and Ship 40 just rolled out for its Flight 13 static fire, a July Starship launch, more likely than ever. My name is Felix, welcome to What About It, let's dive right in. Starship updates. Let's start with the mystery, because it's been evolving day by day, and I think I finally know what we're looking at. There's a Starship nose cone at Starbase that SpaceX has been modifying in a very deliberate, very unusual way. Let me walk you through the sequence, because the progression is the whole story. First, SpaceX installed a bracket on the cone near the top. At first glance, it looked almost like a manhole installation, the kind of access hatch you'd expect for a crew or inspection port. But the position was strange, almost at the very top of the nose cone. Then they tack-welded a jig underneath that bracket. A jig, in manufacturing terms, is a temporary guide. You use it to position something precisely before you commit to the final hardware. Then, a few days later, the picture changed again. SpaceX attached a short pipe socket to the bracket, and the jig was gone. In its place, 6 distinct holes in the hull arranged in a pattern directly under that pipe socket. You tell me, does this look like a fuel transfer interface? The pipe socket isn't wide enough for people. At most, it's around 80 centimeters across. That's too narrow for a crew transfer tunnel. But it's exactly the kind of size and configuration you'd expect for a propellant transfer connection. And that points in a very specific direction, HLS. But not the crew side of HLS, the fuel transfer side. Here's the logic. Refueling a Starship in orbit, which is the single most important capability SpaceX needs to unlock for the Moon and Mars, requires a docking and propellant transfer interface between two ships. If SpaceX is building a test article to demonstrate that transfer, this is exactly what the hardware would start to look like. Now, if this is a fuel transfer interface, there's a question worth asking. A Starship has 2 main propellant tanks, liquid oxygen and liquid methane. So you'd expect 2 transfer interfaces, one for each tank. This nose cone interface could be one of them. The other could be at the engine section, where the existing fueling interface already sits, so there might not be a need for a second added part up top. Put it all together, and we may be looking at an HLS propellant transfer test article. If that's what this is, it would be a sensation. It would mean SpaceX is moving toward the orbital refueling demonstration that NASA has been waiting on, the single biggest technical gate between where Starship is now and a crewed lunar landing. So I want to be clear, this is an interpretation, not a confirmation. But the progression of that hardware, bracket to jig to pipe socket with 6 holes, is exactly the kind of connection pattern you'd see for a propellant interface. The large tube for propellant, the smaller holes for data and other connections. This might not be flight hardware yet. This nose cone might very well be intended for structural testing at Massey's. But we're getting closer. Speaking of Massey's, here's the most direct Flight 13 news. In the night from June 23rd to June 24th, SpaceX rolled Ship 40 to Massey's with all of its engines installed. Jordan and Amy were out there again. 3 sea-level Raptor 3 engines, 3 vacuum Raptor 3 engines, all in place. This is the rollout we've been waiting for. So what's next for Ship 40? The static fire campaign. With engines installed, Ship 40 will likely go through a spin prime first, where the turbopumps are spun up without ignition to verify the fuel flow. Then the main event, a full 60-second static fire on the Massey's test stand, the same kind of test Ship 39 passed before Flight 12. That long-duration burn validates the entire propulsion system at flight conditions. If the static fire goes cleanly, Ship 40 rolls back to the production site for final checkouts, then it's flight ready. The ship side of Flight 13 is almost done. On the booster side, the next move is Booster 20 rolling to the launch site for its own static fire at Pad 2. And once both vehicles have completed their static fires, we are only a very short stretch from the launch. So how short are we talking? Let's look at Flight 12 for reference, but with a caveat. Flight 12 was the first flight of version 3 hardware on a brand new pad with multiple static fire aborts and reworks along the way. From Booster 19's successful 33-engine static fire in mid-April to the actual launch on May 22nd, you're looking at roughly 5 weeks. But a big chunk of that was the extra wet dress rehearsals and the careful, deliberate pace SpaceX took, specifically because everything was new. Flight 13 should move faster. The pad is proven, the hardware is a known quantity now. There's far less first-time risk. So once Ship 40 and Booster 20 clear their static fires, I'd expect a tighter timeline to launch. We're talking a couple of weeks, not 5, assuming no surprises. That keeps us right in line with Shotwell's early July target, maybe slipping a touch, but close. Sometimes you just have to follow the paper trail.
Every website you visit, every search you run, it all leaves a digital footprint. Your ISP can see it. Advertisers use it to build a profile on you, serve targeted ads, and some retailers even adjust prices based on your location. That is not fair. Today's sponsor Surfshark encrypts your connection and hides your IP address so your online activity stays yours. But it's more than a VPN. It comes with a built-in ad blocker that strips out trackers before they reach you and a data breach alert system that notifies you if your personal information shows up in a leak. Plus a tool that checks incoming emails for phishing scams. You know? And there's more. One account covers unlimited devices. Your phones, laptops, tablets, your whole household, all under one subscription. And if you travel, it connects through servers in over 100 countries so you can access your content wherever you are. Unlock 4 extra months of Surfshark VPN, head to surfshark.com/Felix or use code Felix at checkout. Click the link, try it out today, help What About It.
Back to Starbase and a gas problem. A couple of episodes back, we covered SpaceX's plan to build a natural gas pipeline from the port of Brownsville to Starbase to solve the tanker truck problem. We now have more information, including a name. SpaceX is calling it Starpipe.
Star-Lord. Who?
Yeah, so just to be clear, we have Starpipe going to Starbase fueling Starship. With star methane? To recap the why, a single Starship launch needs around 230 tanker trucks worth of propellant and commodities. At the cadence SpaceX wants, daily and eventually more, trucking that volume becomes physically impossible. Starpipe
Who?
is the answer. A dedicated underground pipeline carrying natural gas from the port directly to the launch site where it gets liquefied into methane on site. This is the kind of permanent infrastructure investment that tells you SpaceX isn't planning for a handful of launches a year. They are planning for an industrial operation that runs continuously. And they'll need these pipelines for every single Starship pad they're planning. Let's continue the paper trail. Here's a NASA report that dropped this week. It contains some genuinely eye-opening Starship numbers and shows why SpaceX will need these pipelines soon. We finally have some hard numbers. NASA's Office of Inspector General released a report on June 22nd about the agency's launch infrastructure. It is creatively titled IG 26010. The headline finding is that NASA's launch infrastructure at Kennedy Space Center is aging and lacks the capacity for the launch cadence that's coming. Nothing new, but buried inside are 2 Starship facts that are worth pulling out. First, the cadence. According to this report, SpaceX plans to launch Starships as often as every 8 days from the Florida coast as an early step. Every 8 days. That's 45 Starship launches per year from KSC alone. Second, and this is the number that's really a small sensation, the report states that a single HLS lunar landing requires at least 15 Starship launches just to deliver propellant to low Earth orbit. We finally have a confirmed number. Let me explain how that works and why, even if it sounds crazy, it makes a lot of sense, because it's the key to understanding the entire Artemis architecture. Yay, you've reached the middle of the video. You made it. Thank you from the bottom of my heart for watching and liking the video. If you're among the 40% who haven't subscribed yet and there was at least one video you learned something new from, it would mean the world to me if you did. It's free, and it genuinely helps more people find my channel. Want to make my world even easier? There is only one place you'd rather be, the Y Members Club on Patreon and right here on YouTube. Click the card or the join button right here under the video. You are the reason we keep doing this. Thank you so much. You rock. To land humans on the moon with Starship, you can't just launch one rocket and go. Blue Origin won't do that either. The HLS lander needs to be fully refueled in orbit before it can make the trip to the moon. It's way heavier than Apollo with a lot more ambition. So the sequence is this. First, SpaceX launches a propellant depot, a Starship configured as an orbiting fuel tank. Then a series of tanker ships launch, one after another, each one rendezvousing with the depot and transferring its load of liquid methane and liquid oxygen. According to NASA, that's at least 15 launches just to fill the depot. Then, finally, the HLS lander itself launches, docks with the full depot, takes on all that propellant, and only then heads to the moon with full tanks. And this is why the infrastructure report matters. The report estimates that this Starship operation will generate around 19,000 additional heavy truck trips per year at Kennedy Space Center alone. Just for hardware, propellant, and material. Roads and bridges at KSC, many built in the 1960s, are already in marginal condition. NASA is openly flagging that its own infrastructure may not be able to keep up with what SpaceX is about to do. So the picture this report paints is striking. One moon landing equals a campaign of at least 16 Starship launches in total, 15 or more to fuel the depot, plus the lander itself. So, one launch every 8 days, that's 120 days. Wait, don't forget about Starbase and later Slick 37. SpaceX should be able to fill the depot for Starship launches roughly every 2 months, if they have 2 pads running a refueling flight every 8 days. And that would even leave them with 1 pad for other things, and once Slick 37 is ready, they can get this time down to around a month, still just holding the 8-day cadence. And before you ask, the 15-flight number likely already includes boil-off. Why? A reasonable number for fuel payload on a propellant flight to a depot would be around 150 tons. That's on the lower end of what we can expect. A version 3 Starship has a capacity of roughly 1,600 tons. That's a bit more than 10 flights. So the boil-off could be as much as 33%. A reasonably well-insulated Starship should be able to keep the boil-off percentage at around 10% per month. So the boil-off problem is factored into this.
Maybe a month-ish away from Flight 13. Okay. And then we should fly every month.
When Shotwell says monthly cadence for the rest of 2026 and more later, this is why. The moon program literally cannot happen without it. Testing alone will require many launches. So what about those other pads? We were back in the air over the Cape this week with a fresh flyover, and the Florida build-out is picking up speed in a big way. Let's start at Slick 37. The first Mechazilla tower is now stacked up to 2 segments, and we got a beautiful view of it from the helicopter. It took SpaceX 43 days to stack the last tower at Pad 2. By that estimate, we're looking at yet another Mechazilla by the end of July. I know, there will be a flood of comments asking if 15 tanker flights for 1 HLS flight to the moon are worth it. Think of it this way. If it takes only about a month to fill the depot and costs about $10 million per flight, we're looking at $150 million for about 100 tons of payload to the moon. Blue Origin plans for Mark II to send 20 tons to the moon for $3.4 billion for Artemis 5. That includes development costs. But they will need to refuel several times as well, and a New Glenn flight costs around $80 million. You see the problem? Per-flight costs will make a huge difference if you need to launch frequently. And SpaceX is really good at lowering per-launch costs. They did this with Falcon 9 like no one else. So if SpaceX is able to lower these to, let's say, 10 to 20 million per Starship flight, it will be incredibly cheap. Here's the fun part. Let's look at the worst-case scenario. Let's say they keep it at 100 million per Starship flight and just can't lower it further for whatever reason. That would still make it far cheaper than an SLS launch, even though it would include 15 $100 million launches. And instead of not even being able to land on the moon like SLS, it would send a fully reusable lander to the moon with substantial crew and cargo capabilities. And that's the worst-case scenario. I personally expect them to go below 10 million eventually. Mass production and full reusability will likely make these prices possible, even if it feels unachievable right now. So they have at least 3 pads operational by early 2027, likely 4 with a 5th in active production. The tower isn't the only thing happening at Slick 37. You can see tons of pedestals being placed across the ground, very likely the foundations for a tank farm. And SpaceX has started pouring the first concrete foundations as well. After months of this site looking mostly empty, work at Slick 37 is now massively picking up. This is the moment Slick 37 turns from a graded plot into an actual launch complex. And just as I wanted to finish this episode, NASA Spaceflight's Max Evans reported a very special transport from Roberts Road to Slick 37. The chopsticks for the first of 2 towers at Slick 37 have now been delivered to the construction site as well. Over at Roberts Road, the Gigabay is very far along now as well. It's almost entirely covered in cladding, and the gigantic bay door openings are now fully visible. Here's the detail that really sells the scale. Look at the full-size dump trucks and the heavy equipment parked around the building. Next to the Gigabay, they look like toys. This is one of the largest buildings SpaceX has ever constructed, and from the air, you finally get a sense of just how massive it is. And of course, we also got some good images of Pad 39A. The plan here seems to be to finish things up ASAP. Not much is left of the large construction efforts that dominated this site for so long. There's still plenty of detail work happening, the finishing touches that take a pad from structurally complete to launch ready. But the heavy lifting is essentially done. Honestly, the pad gets prettier with every flyover we do. Put the NASA report next to this flyover and the connection is obvious. Every 8 days, at least 15 launches per moon mission, an entire second launch complex rising at the Cape. The infrastructure we're watching get built is the physical answer to the cadence NASA is writing about. SpaceX is constructing the capacity to actually do this. And this doesn't even include the efforts I reported on earlier last month. Pecan Island in Louisiana could become substantially larger than Starbase. The pieces are all moving at once. Flight 13 is the next one to fall into place, and it will need to show the most important metric: reliability. And that's it for today. Smash that like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. Our all-time favorite Raptor engine design and countless others are there for you to explore. Click the card or the US or worldwide link in the description. History is being written in real time. If you want to catch the other historic stories from recent weeks, click the video on screen and continue the journey. Thank you for watching, and I'll see you again in the next episode.